Close your eyes and picture the sun, not as a distant ball of fire, but as a living, breathing presence in the cosmos. Like the steady rhythm of your own heartbeat, our star moves through cycles of energy and calm, activity and rest. Right now, we find ourselves in one of its most fascinating phases, the solar minimum. This is when the sun grows quiet, its fiery temper softening into a deep cosmic hush. Sunspots fade, solar flares become rare, and the entire solar system seems to hold its breath. But this quiet is not empty. It's a time of mystery, when the sun's hidden rhythms whisper secrets about the universe and our place within it. As you settle in, let this story carry you into the gentle embrace of the solar minimum, where space itself feels softer and the stars shine just a little brighter against the velvet dark. Where are you joining us from tonight, and what does the sky look like where you are? Let's drift together into this celestial lullaby. Now, let's step into the graceful rhythm of the sun itself, a dance as old as time. Think of it like the steady rise and fall of your own breath. Inhale, exhale, a pulse that never falters. The sun moves this way too, not in seconds or minutes, but in cycles that stretch across years. Every 11 years or so, our star reaches a peak of activity, its surface alive with sunspots and eruptions, as if it's singing at the top of its lungs. But then, just as surely, it quiets down. The solar minimum is that moment when the sun exhales, when its energy softens into something quieter, like the pause between heartbeats. This isn't stillness, it's balance. The universe knows that even the brightest flames need moments of rest, and during this quiet phase, the sun isn't fading. It's gathering itself, untangling its magnetic fields, preparing for the next crescendo. It's a reminder that rhythm is everywhere, from the smallest heartbeat to the grandest star. And right now, we're witnessing the sun in its most serene state, a celestial lullaby written in light and silence. Long before telescopes sharpened our view of the cosmos, people noticed when the sun grew quiet. Imagine standing under an open sky centuries ago, tracking the dance of light and shadow on the sun's face, only to find it strangely blank. One of the most striking examples is the Maunder Minimum, a period from the late 1600s to the early 1700s, when sunspots nearly vanished. Astronomers of the time, like Edward Maunder, pieced together records showing decades where the sun's fiery freckles all but disappeared. But this wasn't just a scientific curiosity. Cultures across the world wove stories around these quiet phases. Some saw them as omens, a celestial sigh before times of hardship. Others interpreted the sun's stillness as a divine pause, a moment when the gods themselves rested. During the Maunder Minimum, winter landscapes stretched farther south than usual, with frost fairs blooming on frozen rivers, hints that the sun's slumber might whisper to Earth's climate. Yet for all the mystery, these ancient observers understood something profound. The sun's rhythms are part of a larger story, one that connects human history to the heartbeat of the universe. Their records, etched in parchment and memory, remind us that even in stillness, the cosmos is speaking. Now let's pull back the curtain on what's really happening during this quiet phase. Picture the sun not as a static ball of fire, but as a swirling, dynamic ocean of plasma, where magnetic fields twist and tangle like invisible threads. Every 11 years or so, this cosmic loom resets itself. The sun's magnetic field weakens, unraveling those knots that create sunspots. Think of it like a campfire settling into embers. The flames, those fiery loops of magnetic activity, die down, leaving behind a softer glow. At the heart of this process is something called the solar dynamo, a natural engine deep within the sun that generates its magnetic field. During solar minimum, this engine idles. The sun's poles, which usually host strong magnetic charges, grow quiet, almost as if the sun is taking a deep breath before the next cycle begins. Without those intense magnetic knots bubbling to the surface, sunspots fade away, leaving the sun's face smooth and unmarked. But here's the beautiful part. This isn't chaos. It's a rhythm, as natural as the tide rolling out. The solar minimum is the universe's way of hitting pause, letting the sun gather strength for its next act. And just like the quiet after a storm, there's a strange peace in knowing even the fiercest stars need their rest. Now let's turn our gaze from the sun to Earth, where this cosmic quiet paints a different kind of picture in our skies. During solar minimum, the usual fireworks of space, whether solar flares and coronal mass ejections, fade into near silence. Without those explosive bursts of energy, the dazzling auroras that dance near the poles become rare, almost shy. Imagine the northern lights not as a roaring river of color, but as faint whispers of green and purple, like watercolor brushed lightly across the night. This lull in activity brings a unique kind of beauty. With fewer solar storms disturbing Earth's magnetic field, the upper atmosphere settles into a calmer state. Astronomers and stargazers cherish this phase, as the reduced solar interference makes the stars appear sharper, brighter, as if the universe itself is holding its breath. Even the ionosphere, that layer of charged particles high above us, becomes more stable, creating ideal conditions for certain types of radio communication. Yet there's a trade-off. Without the sun's energetic outbursts, the solar wind, a stream of particles constantly flowing from the sun, weakens to little more than a gentle breeze. This allows more cosmic rays from deep space to slip into our solar system, an invisible rain of high-energy particles that scientists carefully monitor. So while the skies may lack the drama of auroras, they hum with subtler, quieter mysteries, reminding us that even in stillness, the cosmos never truly sleeps. Now, let's take a closer look at what's happening beneath the sun's serene surface during this quiet phase. Picture the sun's magnetic field like a tangled blanket, twisted and knotted during its more active periods. But as the solar minimum settles in, that blanket slowly smooths out, the knots loosening, the tension easing. This calming of the magnetic field is what leads to fewer sunspots and a dramatic drop in solar storms. Without those chaotic twists and turns, the sun's outer atmosphere, the heliosphere, it becomes a quieter, more peaceful place. Solar flares, those sudden bursts of energy that can send shockwaves through space, become rare. Coronal mass ejections, The massive eruptions that fling charged particles across the solar system dwindle to almost nothing. It's as if the sun itself is taking a deep breath, settling into a state of rest. This magnetic calm doesn't just affect the sun, it ripples outward, influencing the entire solar system. The solar wind, usually a turbulent stream of particles, slows to a gentle flow. Space around Earth and other planets becomes less chaotic, with fewer disruptions to satellites and communication systems. Even the protective bubble of the heliosphere, which shields us from the harshest cosmic rays, adjusts to this quieter rhythm. Yet, this tranquility isn't absolute. While the sun's magnetic field may be in slumber, it's still at work, shifting and reorganizing itself in subtle ways. Scientists watch closely as the polar magnetic fields begin their slow reversal, a process that marks the transition toward the next solar cycle. So even in this quiet phase, the sun is preparing for its eventual return to activity, a reminder that rest is just another part of its eternal dance. But what does this cosmic quiet mean for us here on Earth? As the sun settles into its solar minimum, scientists have long wondered about its subtle influence on our planet's climate. Some believe these periods of reduced solar activity might bring slight cooling, like a gentle whisper from space, brushing against Earth's atmosphere. One of the most talked about examples is the so-called Little Ice Age, a stretch of cooler temperatures between the 14th and 19th centuries. During this time, winters were harsher, rivers froze over more frequently, and glaciers advanced, coinciding with periods like the Maunder Minimum, when sunspots nearly vanished. Yet the connection isn't as straightforward as it might seem. While the sun's energy dips slightly during a solar minimum, the change is subtle, like turning down a dimmer switch just a notch. Earth's climate is a complex dance of many factors, from ocean currents to greenhouse gases, making it hard to pin cooling trends solely on the sun's quiet phases. Some researchers argue that volcanic eruptions or shifts in atmospheric circulation played a bigger role in the Little Ice Age than solar activity alone. Still, the idea lingers like a soft echo. Studies suggest that during deep solar minima, the sun's weakened ultraviolet light might ripple through Earth's upper atmosphere, nudging weather patterns in ways we're only beginning to understand. It's a reminder that even in its calmest state, the sun never truly stops touching our world. Whether these quiet phases leave a faint chill in the air or simply blend into the background of Earth's ever-changing climate, they add another layer of mystery to the bond between our planet and its star. And as the sun rests, so too does the debate, a gentle back and forth among scientists, much like the ebb and flow of sunlight on a winter's day. While the sun's quiet phase stirs debate about its effects on Earth, there's one place where its calm is undeniably welcome: outer space. During a solar minimum, the cosmos becomes a gentler environment for astronauts and spacecraft alike. With fewer solar flares and coronal mass ejections, the sun's tantrums fade into silence, reducing the bombardment of high-energy particles that typically pose risks to both technology and human explorers. Imagine floating aboard the International Space Station during this tranquil phase. The usual alerts for solar storms grow rare, replaced by the steady hum of instruments monitoring a quieter sun. astronauts can gaze out at Earth without the looming threat of sudden radiation spikes, their cosmic neighborhood feeling just a little safer. Even satellites breathe easier, their delicate electronics spared from the frying effects of intense solar winds. This isn't just about comfort, it's about opportunity. Space agencies often time missions to coincide with solar minima, knowing that the reduced radiation allows for longer, more stable operations. Probes venturing toward the Moon or Mars face fewer interruptions, while telescopes studying distant stars enjoy clearer views, unimpeded by solar interference. The quiet sun becomes an ally, its subdued mood opening a window for exploration. Yet this peace comes with its own curiosities. With the solar wind dialed down, more cosmic rays, high-energy particles from deep space, seep into our solar system. It's a trade-off, fewer solar storms, but a subtle increase in background radiation. Even in its rest, the sun reminds us that space is never entirely still. For now, though, astronauts and their machines can relish the calm, drifting through a cosmos that feels, for a moment, a little more forgiving. And as we look ahead to lunar bases and interplanetary journeys, the solar minimum offers a glimpse of a future where humanity steps into the void, are guided by the rhythms of our star, sometimes fiery, sometimes hushed, but always shaping the way we explore. Now, let's turn our gaze to the sun's shimmering crown, the corona. Even in its quiet phase, this outer atmosphere holds a quiet beauty all its own. During solar minimum, the corona undergoes a subtle but striking transformation. The fiery tendrils that usually stretch wildly in all directions begin to retreat, pulling closer to the sun's equator like delicate threads drawn toward a spindle. What emerges is a symmetrical halo, a perfect ring of light encircling our star, as if the cosmos itself has paused to admire its own handiwork. This isn't just a visual change, it's a sign of the sun's magnetic field settling into simplicity. Without the chaos of sunspots and active regions, the corona's structure becomes more orderly, its streamers aligning neatly along the solar equator. Picture a dancer's flowing ribbons, once whirling in every direction, now swaying gently in unison. The effect is almost meditative, a celestial ballet performed in slow motion. For scientists, this calm corona is a rare opportunity. With fewer eruptions obscuring the view, telescopes can study the sun's outer layers in unprecedented detail. The faintest structures, usually lost in the glare of solar storms, now stand out like fine etchings on glass. Even the solar wind, typically a turbulent gale, eases into a steady breeze, its origins traceable back to these quiet equatorial streamers. Yet this serenity is fleeting. As the sun stirs from its slumber, the corona will once again erupt into complexity, its symmetry shattered by the return of magnetic turmoil. But for now, it remains a testament to the quiet elegance of the solar minimum, a reminder that even the most dynamic forces in the universe have moments of stillness when beauty takes center stage. And as we marvel at this delicate halo, we're reminded that the sun's pauses are as meaningful as its storms, each phase a chapter in an endless cosmic story. Now, let's shift our attention to the solar wind, that invisible river of charged particles streaming endlessly from the sun. During the height of solar activity, this wind rages like a tempest, hurling bursts of energy across the solar system with enough force to rattle Earth's magnetic shield. But when the sun enters its quiet phase, something remarkable happens. The solar wind softens, easing into a gentle flow, more like a whisper than a roar. Imagine standing by a roaring waterfall, the sound deafening, the spray fierce. Then, as if someone turned down the volume, the cascade dwindles to a trickle, the noise fading to a hush. That's the shift between solar maximum and minimum. The particles streaming from the sun slow their pace, their intensity dialed back, as if the cosmos itself has taken a deep breath. This gentler solar wind doesn't just change the mood of space, it reshapes the environment around our planet. Without the usual bombardment, Earth's magnetosphere relaxes, like a shield lowered after battle. Auroras, those dazzling light shows, grow rare and faint, their fiery curtains replaced by a quieter sky. Even the planets feel the difference. Mars, with its thin atmosphere, loses some of the protective buffer against cosmic rays, while distant spacecraft sailing through the solar system encounter fewer turbulent gusts. Yet this calm isn't empty. The slower solar wind carries its own secrets, flowing in steady streams from the sun's cooler, quieter regions. Scientists trace these breezes back to the corona's elegant equatorial streamers, watching as they weave through space with newfound clarity. It's a reminder that even in stillness, the sun is never truly silent, just speaking in a softer voice, one that invites us to lean closer and listen. And as we do, we're reminded that the universe has rhythms beyond the dramatic. The solar wind's quiet phase is a cosmic lullaby, a fleeting moment when the heavens trade fury for grace, and the planets drift through a gentler, kinder space. But here's something fascinating about the sun's quiet phase. It doesn't just calm the solar wind, it opens a hidden door for cosmic rays, those mysterious high-energy particles racing through the galaxy. Normally, the sun's fierce solar wind acts like a bouncer, pushing many of these rays away from our solar system. But when the wind weakens during solar minimum, that defense relaxes and more cosmic rays slip through. Picture the solar system as a bustling city, with the solar wind as its police force keeping order. During solar maximum, they're everywhere, patrolling the streets, keeping troublemakers at bay. But when the force steps back during minimum, the city's edges grow porous, and cosmic rays, those interstellar wanderers, start filtering in. These particles, born from exploding stars and distant cosmic events, now have an easier path to reach us, dancing unseen through the quiet spaces between planets. For Earth, this means more cosmic rays brushing against our atmosphere, sparking subtle changes. Scientists track these shifts using high-altitude balloons and satellites, watching as the rays leave faint trails of ionized particles in their wake. Even astronauts in space notice the difference, as the quieter sun means their spacecraft get peppered with more of these energetic visitors. It's a reminder that the cosmos is never truly empty, just filled with things we can't always see. And yet, there's beauty in this invisible invasion. Cosmic rays carry stories from far beyond our solar system, whispers of supernovas and black holes etched into their energy. During solar minimum, We get front row seats to their silent performance, a reminder that even when the sun rests, the universe never stops moving. So while the solar wind's hush brings calm, it also invites us to ponder the deeper rhythms of space, where every quiet moment hides a universe of motion. Now, let's turn our gaze to one of the most puzzling features of the solar minimum, the strange vanishing act of sunspots. These dark blemishes on the sun's surface, often as wide as Earth, suddenly grow scarce during this quiet phase, leaving the sun's face smooth and unmarked. It's as if the stars in the night sky began to fade one by one, leaving behind an eerie, blank canvas. Sunspots are born from knots in the sun's magnetic field, where intense magnetism slows down the flow of heat, creating cooler, darker patches. During solar maximum, they cluster like freckles, but as the sun winds down, they dwindle away. Scientists still don't fully understand why they disappear so completely during minimum, or why some cycles produce fewer spots than others. It's a cosmic mystery that keeps astronomers watching and wondering. Imagine stepping outside on a clear night, only to find half the stars have silently blinked out. That's what the sun's surface looks like during solar minimum, a vast, golden expanse with hardly a spot in sight. For centuries, observers tracked these absences, like the famous Maunder Minimum in the 1600s, when sunspots nearly vanished for decades. Some wondered if the sun itself was fading, while others saw it as an omen. Today, we know it's just part of the sun's natural rhythm, though the exact mechanics remain elusive. What makes this even more intriguing is that sunspots aren't just missing, they're expected to be missing. Their absence is a sign that the sun's magnetic field is resetting, like a clock winding down before it can be wound up again. Without these tangled magnetic knots, the sun's face becomes serene, almost peaceful, yet their disappearance leaves scientists with questions. Could a prolonged absence of sunspots hint at deeper changes in the sun's behavior, or is it simply part of a grander cycle we've yet to fully decode? For now, the blank sun remains one of space's gentle enigmas, a reminder that even our closest star holds onto its secrets. And just as the night sky feels different when stars are few, the solar minimum transforms the sun into something unfamiliar, a quiet giant resting between acts of its fiery drama. Now, let's journey to the sun's poles, where another quiet transformation unfolds during solar minimum. Like the slow turn of seasons on Earth, the sun's magnetic poles undergo a gradual reversal, a cosmic dance that happens without fanfare or spectacle. During solar maximum, the sun's magnetic field is a tangled web, with sunspots and flares marking its chaotic energy. But as the sun settles into its quiet phase, something remarkable happens. The magnetic fields at the poles begin to weaken, then flip entirely. North becomes south, and south becomes north, as if the sun is quietly resetting its internal compass. This reversal isn't sudden. It's a process that can take months or even years, unfolding with the patience of a tree shedding its leaves in autumn. Scientists observe this shift through subtle changes in the sun's polar magnetic fields, which grow weaker until they finally switch polarity. It's a bit like watching the hour hand of a clock. You won't notice it moving, but over time, the change becomes clear. What's fascinating is that this flip isn't unique to our sun. Other stars with magnetic activity likely experience similar reversals, hinting at a universal rhythm in the cosmos. Yet, even with this knowledge, the exact triggers and consequences of the sun's polar flip remain topics of study. Does it influence the strength of the next solar cycle, or is it simply part of a larger, uncharted pattern? For now, this silent shift reminds us that even the grandest cosmic events can unfold with quiet elegance. The sun's poles reverse without a sound, a gentle reminder that the universe moves to its own timeless rhythm, far beyond the rush of human years. And just as winter gives way to spring, the sun's magnetic fields will eventually stir again, ready for another cycle of activity. Now, let's tune into an unexpected benefit of the solar minimum, one that might surprise you. While the sun's quiet phase means fewer dazzling auroras, it also brings a hidden gift to radio communications here on Earth. During solar maximum, the sun's intense activity bombards our planet with charged particles, causing the ionosphere, the upper layer of Earth's atmosphere, to become turbulent. This chaos can scatter or absorb radio waves, making long-distance signals crackle and fade. But when the sun slips into its minimum, the ionosphere calms down like a stormy sea, settling into glassy stillness. With fewer solar flares and eruptions, the ionosphere becomes more stable and predictable. This creates ideal conditions for radio waves to travel farther and clearer, bouncing effortlessly between the Earth's surface and the ionosphere. It's as if the sun, usually a loud broadcaster, has switched to listening mode, allowing Earth's own signals to take center stage. Amateur radio operators and aviation communicators often notice this shift. Distant stations that were once buried in static suddenly come through crisp and clear, as if the universe itself has turned down the noise. Even emergency services relying on long-range radio find their transmissions more reliable during these quiet solar periods. But why does this happen? The answer lies in the ionosphere's layers, which behave differently under the sun's gentle touch. Without the usual bombardment of solar energy, the lower layers become less dense, letting radio waves reflect more efficiently. It's like swapping a thick, foggy window for a clean pane of glass. The signal passes through with ease. This quiet enhancement isn't just practical, it's poetic. In a cosmic twist, the sun's retreat gives Earth's own voices a chance to travel farther, connecting people across continents with newfound clarity. So the next time you hear a distant radio signal cutting through the silence, remember, it's the solar minimum lending us its quiet so we can be heard. Now, let's turn our gaze from the skies to the Earth, where the sun's quiet phase weaves its subtle influence into the lives of creatures great and small. While we humans rely on technology to notice the solar minimum, some animals might sense it instinctively through Earth's magnetic field. Birds, sea turtles, and even butterflies are known to navigate using the planet's magnetic cues, like invisible highways guiding them across continents and oceans. During the solar minimum, the sun's weakened magnetic influence allows Earth's own magnetic field to dominate, possibly making these natural compasses more stable. Imagine a migratory bird, mid-flight, finding its path a little clearer, as if the cosmic static has been dialed down. Scientists speculate that reduced solar activity could subtly alter how animals perceive magnetic fields. For instance, sea turtles reliant on geomagnetic imprints to return to their birth beaches might experience fewer disruptions in their long journeys. Similarly, monarch butterflies, with their delicate internal compasses, could benefit from a steadier magnetic environment as they traverse thousands of miles. Yet, this connection remains one of astronomy's gentle mysteries. While we can't ask animals if they notice the sun's quiet, their uninterrupted migrations during solar minima hint at an unspoken harmony between celestial rhythms and earthly life. It's a reminder that the cosmos doesn't just shape our skies, it whispers to the very instincts of the creatures sharing our planet. So the next time you see geese tracing a V across the twilight or a turtle vanishing into the waves, consider this: their journey might be guided in part by the sun's silent phase, a cosmic lullaby for wanderers of land, sea, and air. Long before telescopes and satellites, people looked up at the sun and wove stories to explain its changing moods. Across cultures, periods of solar quiet were often seen as signs sometimes divine, sometimes ominous. The ancient Chinese interpreted a spotless sun as the celestial dragon resting, while Norse myths whispered of the wolf skull pausing his chase across the heavens. Even the Inca, who worshipped the sun as a god, recorded times when its diminished warmth was thought to signal a deity's displeasure or retreat. In Europe, the Maunder Minimum's eerie quiet coincided with the coldest years of the Little Ice Age, leading many to believe the sun itself was grieving, or that the heavens were withholding favor. Farmers' almanacs from the time spoke of prolonged winters as the sun's stolen breath, while poets imagined it as a slumbering monarch, its golden crown dimmed. Some cultures saw these phases as sacred pauses, moments when the universe inhaled before exhaling anew. These myths, though born of wonder rather than science, reveal a profound truth. Humans have always sensed the sun's rhythms, even without understanding them. Today, we know the solar minimum as a natural ebb in stellar activity, but there's still something hauntingly beautiful in the idea of our star taking a cosmic nap, a reminder that even the mightiest forces need rest. So as we drift towards sleep, picture the sun not as a distant ball of plasma, but as an ancient storyteller, its quiet phases spinning tales across the ages. Now, let's turn our gaze to the tools that bring the sun's quiet moments into sharp focus. Modern telescopes and spacecraft have peeled back the layers of mystery surrounding the solar minimum, revealing a side of our star that ancient skywatchers could only imagine. The Solar and Heliospheric Observatory, known as SOHO, has been a silent sentinel in space for decades, capturing the sun's every whisper. Its instruments detect the faintest changes in solar radiation, painting a picture of a star in repose, its surface smooth, its flares rare, its magnetic field relaxed. Then there's the Parker Solar Probe, humanity's closest envoy to the sun, daring to skim through the corona itself. During the solar minimum, this intrepid spacecraft measures the gentle ebb of the solar wind, a breeze so faint it's like the sun is sighing. These missions uncover secrets hidden in the quiet, like how the corona, usually a crown of fiery loops, becomes streamlined and symmetrical, as if the sun has folded its turbulent cloak neatly around itself. What's truly remarkable is how these tools reveal the solar minimum not as an absence of activity, but as a different kind of rhythm. Soho ultraviolet eyes catch delicate plumes of plasma rising from the sun's poles, while Parker samples the oddly calm solar wind, finding it rich with clues about the star's inner workings. Together, they show us that the sun's quiet phase is anything but empty. It's a time of subtle shifts and whispered secrets, a cosmic lullaby waiting to be decoded. So as we marvel at these discoveries, remember the same star that once inspired myths now speaks to us through data and light, its quietest moments echoing just as powerfully as its storms. Now, let's peer into the future where science meets the art of cosmic forecasting. Predicting the next solar minimum isn't just about dates and data. It's like listening for the sun's gentle yawn before it settles into another long nap. Scientists use a symphony of clues, sunspot records, magnetic field measurements, and even the sun's own heartbeat-like cycles to estimate when the next quiet phase will arrive. The sun operates on an 11-year rhythm, but it's not always perfectly punctual. Sometimes its naps come early, sometimes late. Right now, researchers believe the next minimum could arrive around the late 2020s, though the sun loves to keep us guessing. Satellites like SOHO and the Parker Solar Probe continue to monitor subtle changes, tracking the slowing pulse of solar activity as the star prepares to wind down. What's fascinating is how these predictions resemble a lullaby, a slow, soothing descent into calm. As the sun's magnetic fields begin to weaken and sunspots fade, it's as if the star is folding its fiery arms, ready to rest. But even in this quiet, there's beauty. The corona grows more symmetrical, the solar wind turns to a whisper, and Earth's skies may glow a little less with auroras, yet the universe hums along, undisturbed. So while we can't set an exact alarm for the sun's next nap, we know it's coming, and when it does, it'll be another chapter in the star's eternal dance of activity and rest. A reminder that even the mightiest forces in the cosmos need their quiet moments too. Now, let's take a moment to appreciate the quiet elegance of the sun during its most serene phase. Picture a flawless golden sphere suspended in the vast darkness of space, its surface smooth and untroubled by the usual chaos of sunspots or fiery eruptions. This is the sun at its most pristine, a celestial masterpiece in repose. Without the usual blemishes of solar storms, the star's face becomes a perfect, radiant disk, like a polished jewel glowing softly against the infinite black. The absence of sunspots gives it an almost otherworldly purity, as if the cosmos itself has paused to admire its own handiwork. During this time, the sun's light feels different, gentler, more even, as though the star has exhaled and let go of its usual turbulence. It's a reminder that even the most dynamic forces in the universe have moments of stillness, where beauty lies not in spectacle, but in simplicity. And against the backdrop of space, this blank sun becomes a symbol of balance, a quiet counterpoint to its more active phases. It's a sight that invites contemplation, as if the universe is whispering to us about the power of calm, the elegance of restraint. So the next time you think of the sun, remember that even in its quietest moments, it holds a kind of perfection, one that shines just as brightly as any solar flare. Now, let's turn our gaze toward the moon and the possibilities that unfold during the sun's quiet phase. Picture a lunar base nestled among the dusty craters, its solar panels soaking up the steady, unfiltered light of a dormant sun. Without the interference of solar storms or unpredictable flares, this becomes an era of unprecedented stability for astronauts living and working on the moon. The calm space weather means fewer disruptions to communication systems, no sudden surges of radiation to scramble delicate equipment, and no need to seek shelter from violent solar outbursts. Instead, astronauts might step outside their habitats to witness a sky where Earth hangs like a blue jewel, while above them, the sun glows with a serene, unwavering light, a far cry from its usual tempestuous self. This tranquility isn't just a comfort, it's a strategic advantage. Scientific experiments could run uninterrupted, lunar rovers wouldn't face unexpected shutdowns, and long-term missions could proceed without the constant threat of solar interference. Even the moon's surface, usually bombarded by solar particles, would experience a rare lull, offering researchers a clearer window into the cosmos beyond. And imagine the view. With no solar flares to distort their instruments, astronauts might train telescopes back at the sun, studying its smooth, unblemished face in perfect detail. Or they could simply pause during a moonwalk, looking up at that golden disk, and feel a connection to the quiet rhythm of the universe, a rhythm that, for now, favors exploration over upheaval. This is the gift of the solar minimum, a chance to reach further, to build and learn in a space that feels, for once, almost peaceful. The moon, so often a symbol of solitude, becomes a haven where humanity can thrive under the gentle gaze of a resting star. But our sun isn't alone in this cosmic quiet. Across the galaxy, countless stars experience their own versions of a solar minimum, each one following its own rhythm. Some stars, like our sun, have regular cycles of activity and rest, while others fluctuate more unpredictably. Take red dwarfs, for example, smaller, cooler stars that can spend years in a subdued state, barely flickering with sunspots. Then there are the massive, fiery giants, whose magnetic storms rage so violently that their quiet phases feel like mere pauses between outbursts. What's fascinating is how these cycles shape the worlds around them. Planets orbiting stars in their quiet phases might enjoy stable climates, free from the chaos of sudden flares. Others, caught near hyperactive stars, could face relentless radiation, making life as we know it nearly impossible. It's a reminder that the universe operates on a grand scale, with each star dancing to its own beat, yet all part of the same cosmic symphony. Our sun's solar minimum, then, isn't just a quirk of our solar system. It's a glimpse into a universal pattern, a moment of stillness shared by stars near and far. And as we study these distant suns, we begin to see that even in the vastness of space, there's a kind of harmony, a quiet understanding that everything, from the smallest red dwarf to the brightest supergiant, takes its turn to rest. But while stars across the universe follow their own rhythms, our sun's quiet phase has a very real impact closer to home, on the technology orbiting our planet. During solar minimum, the sun's gentler touch creates a calmer environment for satellites, almost as if it's stepping lightly to avoid disturbing them. With fewer solar storms and a weaker solar wind, the constant barrage of charged particles that usually wear down satellite components slows to a trickle. This means satellites can operate longer without the stress of extreme space weather. Solar panels, which power these machines, degrade more slowly when they're not being bombarded by intense radiation. Electronics, too, face fewer glitches caused by sudden solar flares. It's as if the sun itself is giving our technology a break, allowing satellites to hum along with fewer interruptions. Even communication benefits from this cosmic calm. Signals traveling between Earth and satellites face less interference when the sun isn't hurling bursts of energy our way. GPS systems become more reliable, weather satellites capture clearer data, and scientific instruments in space can observe the universe without as much solar noise. So while the solar minimum might seem like a quiet, uneventful phase, it's actually a gift to our orbiting machines, a rare window where the sun's gentle behavior helps human technology thrive. And in that stillness, we're reminded how deeply connected we are to our star, even when it's at its most peaceful. Now, let's bring this cosmic quiet down to Earth, literally. Even the plants beneath our feet might sense the sun's gentle shift during solar minimum. While the changes are subtle, they ripple through the natural world in ways we're only beginning to understand. Picture a garden bathed in the softer light of a sleepy sun. Plants, those quiet solar-powered alchemists, rely on sunlight not just for growth, but for timing their lives, when to bloom, when to fruit, even when to shed their leaves. During solar minimum, the sun's energy dips ever so slightly, and while it's not enough to plunge us into darkness, it might whisper to the green world in ways we rarely notice. Some studies suggest that certain plants grow a tad slower when solar activity wanes, as if mirroring the sun's own languid pace. Others might delay their flowering, their internal clocks nudged by the star's quieter rhythm. Even the chemistry of leaves could shift subtly, with pigments like chlorophyll responding to the change in light intensity. It's as if the entire plant kingdom is leaning in, listening to a cosmic lullaby. And then there are the trees, those ancient record keepers. Their rings tell stories of past solar minima, with thinner bands hinting at cooler, slower growing years. Today, scientists study these natural archives to piece together how the sun's quiet phases shape life on Earth. So the next time you stroll through a garden or a forest, remember, the connection between Earth and sun runs deeper than light and warmth. It's a silent conversation, a dance of energy and life, where even the smallest solar sigh can leave its mark on the living world. Now, let's turn our gaze upward to the night sky, where the solar minimum works its quiet magic in a way anyone can appreciate. When the sun enters this restful phase, its reduced activity clears the cosmic stage, allowing the stars to shine with extraordinary brilliance. Think of it like turning down a bright light in a room. Suddenly, everything else becomes more vivid. During solar minimum, the sun's quieter magnetic field and weaker solar wind mean less interference with the light traveling from distant stars. The result: a night sky that feels sharper, deeper, and more alive. Constellations appear crisper, faint stars emerge from the background, and even the Milky Way's glow becomes more pronounced. This clarity isn't just poetic, it's scientific. With fewer solar particles scattering light in Earth's upper atmosphere, Stargazers and astronomers alike revel in the improved visibility. It's as if the universe itself has hit the pause button, offering us a rare chance to see farther and clearer than usual. For those who love to watch the sky, the solar minimum is an invitation. Whether you're spotting Orion's belt from your backyard or tracing the arc of the Big Dipper, the stars seem to whisper secrets usually drowned out by the sun's busier phases. So on the next clear night, step outside and look up. The cosmos is putting on a show, and the solar minimum has given it the perfect spotlight. Now, let's explore how the quiet beauty of the solar minimum has inspired creativity across the ages. Artists and writers have long been captivated by the sun's mysterious calm, weaving its quiet phases into their work with striking imagination. During the Renaissance, painters like J. M.W. Turner used soft, golden hues to capture the sun's subdued glow during periods of low activity, creating landscapes bathed in an almost dreamlike light. These works often portrayed the sun not as a fiery force, but as a gentle presence, hinting at the quiet power of its resting state. Literature, too, has embraced the solar minimum's allure. In the 19th century, poets described the sun's quiet phases as moments of cosmic reflection, where the heavens seem to pause and breathe. Emily Dickinson once likened it to a lidded eye, watching the world with serene stillness. Fast forward to modern science fiction, and the solar minimum takes on new life. Authors imagine it as a time when the sun's silence hides secrets, alien signals slipping through the weakened solar wind, or ancient civilizations waiting beneath its calm surface. These stories transform the quiet phase into a canvas for mystery and wonder. Even today, photographers chase the perfect shot of a blank sun, its smooth face free of sunspots, while filmmakers use its eerie tranquility to set the mood for otherworldly tales. The solar minimum, it seems, isn't just a scientific curiosity, it's a muse, inviting us to see the cosmos through the eyes of dreamers and storytellers. Now, let's step back and see the bigger picture. The solar minimum isn't just a quiet phase, but a vital part of the sun's eternal rhythm. Think of it as the yin to the solar maximum's yang, a cosmic balance that keeps our star in harmony. When the sun blazes with sunspots and storms during its maximum, it's like a roaring fire, full of energy and chaos. But the minimum, that's when the flames settle, leaving behind glowing embers. One couldn't exist without the other. Just as day needs night and breath needs pause, the sun's active and quiet phases depend on each other to maintain the delicate dance of our solar system. This balance isn't just poetic, it's practical. Without the solar minimum, the sun's magnetic field wouldn't reset, its storms would grow unchecked, and the very fabric of space around us would lose its rhythm. The quiet phase gives the sun time to recharge, like a deep cosmic exhale before the next burst of activity. Ancient philosophies understood this duality well. The idea of yin and yang, opposing yet complementary forces, mirrors the sun's cycle perfectly. Even modern science agrees, the minimum isn't a sign of weakness, but a necessary stillness that prepares the star for its next fiery chapter. So when we gaze at the sun during its quiet phase, we're not just seeing a dormant giant, we're witnessing half of a grand celestial balance, a reminder that even the mightiest forces in the universe need moments of rest. And in that stillness, there's a beauty all its own, the quiet assurance that the dance will continue, as it has for billions of years. Now, let's take a moment to slow down and connect with the sun in its quietest state. Close your eyes if you'd like, and picture the solar minimum, a golden orb hanging in the vast darkness of space, smooth and unblemished, like a polished gem. No fiery flares, no swirling storms, just a gentle, steady glow. Feel its warmth, not as a scorching blaze, but as a soft, comforting light, wrapping around you like a cosmic blanket. Breathe in and imagine the sun's magnetic field settling, its turbulent energy calming into a quiet hum. With each exhale, let go of the day's tension, just as the sun releases its grip on solar winds and storms. This is a time of rest for the star and for you. Notice how the sun's surface, free of sunspots, becomes a perfect circle of tranquility. It's a reminder that even the most powerful forces in the universe need stillness. As you drift deeper into this visualization, let the sun's quiet phase guide you toward your own peace. The same rhythm that governs the cosmos, activity and rest, light and dark, flows through you too. When you're ready, take one more breath, feeling the sun's serene energy fill you with calm. Then, like the solar minimum itself, let everything soften into silence. The universe whispers its lullaby, and you, wrapped in celestial stillness, can finally surrender to sleep. Even as we embrace the quiet beauty of the solar minimum, the sun still holds onto a few cosmic secrets, waiting to be uncovered by curious minds. Scientists continue to wonder how this serene phase affects the delicate dust scattered throughout our solar system. Could the sun's weakened winds allow these tiny particles to drift differently, painting unseen patterns in the space between planets? Another puzzle lies in the subtle ways the solar minimum might influence Earth's atmosphere beyond what we already understand. Some researchers speculate that the quiet sun could alter the chemistry of our upper air in ways we haven't yet measured, like a whisper too faint to catch. And what about the far reaches of the Helios, the vast bubble of space, shaped by the sun's influence? Does it shrink or change texture during these calm periods, like a sigh in the cosmic dark? Then there's the question of life itself. Could the increase in cosmic rays during solar minimum spark unexpected changes in Earth's magnetic shield, or even affect the fragile dance of migratory animals that rely on it? The answers are still out there, floating just beyond our reach, inviting us to keep looking, keep wondering. For now, these mysteries remain like stars half hidden behind a veil, glimpsed but not fully known. And perhaps that's the most beautiful part of the solar minimum. It reminds us that even in stillness, the universe is always moving, always revealing new layers of its quiet magic. So as you drift towards sleep, let these unanswered questions linger like gentle ripples in the dark, carrying you deeper into the wonder of the cosmos. And so, as we come to the end of our journey through the sun's quiet phase, let's take a moment to appreciate the gentle rhythm of the cosmos. The solar minimum isn't just a scientific curiosity. It's a reminder of the universe's quiet grace, a lullaby sung in the language of magnetic fields and solar winds. In this stillness, the sun teaches us that even the most powerful forces need moments of rest, just as we do. Picture the sun now, not as a raging inferno, but as a serene golden orb, its face smooth and untroubled. The solar wind whispers instead of howling, and the absence of sunspots leaves its surface flawless, like a perfectly still pond under a twilight sky. This is the universe in its most peaceful state, a cosmic pause between breaths. For you, drifting towards sleep, let this quiet phase be an invitation to slow down too. Imagine yourself wrapped in the same calm that blankets the solar system during this time. No storms, no chaos, just the steady, gentle hum of space itself. The mysteries we've explored tonight may not all have answers, and that's okay. Sometimes wonder is enough. So close your eyes and let the solar minimum stillness carry you. Feel the warmth of a sun at rest, the hush of a universe that knows how to be quiet. Let it cradle you like a lullaby, soft and endless, as you slip into dreams under its watchful glow. The cosmos is vast, but tonight it sings just for you. If you enjoyed this celestial journey, don't forget to subscribe for more stories that blend science with wonder. Hit the bell so you never miss a moment of cosmic exploration, and let us know in the comments what part of the solar minimum fascinated you the most. Sweet dreams, stargazers. The universe is waiting for you. Now, let's take one last quiet journey together. Picture yourself drifting through space, weightless and at peace, drawing closer to the sun in its most serene state. Its golden light wraps around you, not with the fierce heat of solar storms, but with the gentle warmth of a quiet hearth. The surface, smooth and unmarked by sunspots, glows like a polished jewel against the endless dark. As you float nearer, the solar wind brushes past you, not a roaring gust, but a whisper, soft as a sigh. The sun's magnetic field, usually a tangled web of energy, now lies calm, like a blanket smoothed out after a long day. Even the corona, that halo of plasma, stretches lazily around the sun's equator, a delicate crown of light. Close your eyes and let this stillness sink into you. The universe hums softly here, a melody so faint you might mistake it for silence. There's no urgency, no chaos, just the slow, steady pulse of a star at rest. And as you linger in this moment, the warmth of the sun becomes your own, seeping into your bones, easing every tension. Let this be the last thought you carry into sleep, the image of a sun that knows how to be still, and a universe that holds you in its quiet embrace. The story ends here, but the dream goes on. Good night, traveler. The stars will keep watch until morning. you.